Hello students, welcome back. The final topic here is exponential and logarithmic functions, exponential and logarithmic equations of arbitrary base. Previously, we only had natural exponential and natural logarithmic. What if we have arbitrary base? Well, something hard, of course. That's why all these are optional topics. First problem, we have 7 to the 2x power, and that's going to be quadratic. 7 to the x power is understandable. How do we handle 7 to the x plus first power? Here's the deal. Rewrite this one, which I just highlighted in blue, 7 to the x plus 1 power, like this. 7 times 7 to the x power. So that plus 1 becomes a part of that coefficient 7, and what's left is a quadratic equation. So solve it with respect to 7 to the x power, and we get 7 to the x power is 5/4 or -3, but -3, that's extraneous. That's not going to be valid because exponential is never negative. And this one, we can find out the answer by taking the logarithm. So, I took the log based e, natural logarithm, but this was a bit of an overkilling. It would have been easier from here. X is log base 7 of 5/4. That would have been easier. Log base 7, so that kills up this 7. Natural log, okay, that's good, but it's a little bit difficult way of doing the same thing. How about the next problem? We have something similar. 9 to the x power. 9 is 3 squared, so that's going to be quadratic. And then 3 to the x plus 2 power. And plus 2 will become a part of this coefficient. Second power is 9, so that's what you're going to get. This one, which I just highlighted in red, is becoming like this. 9 times 3 to the x power, so this is 9, and then you can factor like this. And the 3 to the x power is a 2 or 5/2. Both are positive, so both are valid. And then you can take the logarithm to figure those out. Again, here I took natural logs, but it's going to be easier if you take the log base 3. X is log base 3 of 2, or x is log base 3 of 5/2. It's going to be easier this way. Here's another problem. 4 to the x power, that's going to be quadratic. 2 to the x power, that's going to be linear, but how do you take care of this plus 2 and plus 1 power? They're going to be part of coefficients. So this one here, which I just highlighted in blue, became 4 times this, so that became 4 times 2 to the x squared. Now this one, which I'm highlighting in green, plus 2 power, so 2 to the second power, so we end up with 4 times 2 to the x power, and you can factor like this, and you end up with these kind of answers. And this one is extraneous, you can clearly see that. Exponential is never negative. And as for the second one, I can take log base 2. Yes, I can take natural logarithm to do all these, but that's a bit of overkilling. So we dealt with exponential equations with arbitrary base, where we have to adjust the coefficients a little bit. How about some log equations? We're going to be using similar logarithmic rules. So put these two logs together, log of 2x minus 1 times x plus 2. But here, When you remove this log base 5, to the right hand side we have 5 to the second power. You're going to get 25. So instead of e, we get something different. So we end up with this product equal to 25. There goes the quadratic equation. And then you can break up all the parentheses and then take the like terms together into standard form and then factor it back. That's how you can get the answers. Negative 9 over 2 or x equal to 3. This one is going to be okay if you plug in 3, 6 minus 1, okay. 3 plus 2, they're going to be okay. But if you plug in negative 9 halves, this is going to fail. So x equal to 3 only. Here's another example. Similar. 3, we have 9 here. So that's going to be a bit of a problem here. How do I change this into log base 3? It's not going to be hard because 9 is 3 squared. So if you use the change of base formula, you can change this into log base 3. Okay, there you go. This thing here, which is highlighted in red, is equal to this one here. Change of base formula. Log base 3 of top, log base 3 of the base. Up is up, down is down. It's not too bad. And then log 3 of 9 turns out to be 2 because 9 is 3 squared. So we get this expression. Okay, removing the denominator, we got that. And flipping this 2 up there, we get complete square, like this. And then using the log rule, we can put these two together. So we have the square over this x plus 2 equals to 2 right hand side. Now, if you remove this log, we have 3 to the second power, so right hand side will become 9, like this. In the end, we got a rational equation to solve. Flip this denominator to the other side, we get a quadratic equation. Break up parentheses, take the like terms together, and then refactor. Voila, we have 2 candidates of answers. What do you get if you check both? X equal to negative 1 looks okay. Negative 2 plus 5, that's positive 3. Negative 1 plus 2, that's going to be okay. How about negative 7/4? Negative 14 over 4 plus 5. Looks like that's okay. Negative 7 over 4 is 8. That looks okay too. Yep. Both will work out, so we have 2 solutions. No, nothing extraneous in this case. Okay, those are exponential and logarithmic equations of arbitrary base. Not surprisingly, I'm keeping all these in optional topics. Even in STEM algebra, I do those as an advanced topic. That's not something I'm going to emphasize here in business algebra, even though they appear in our textbook a little bit. Okay, so much for chapter 12.